Now we are going to look at various graphs like the displacement versus time graph, velocity versus time graph, and acceleration versus time graph. So here first of all we look at the graphs with reference to the displacement taken on y-axis, displacement versus time, displacement versus time. So displacement time graph, we call it as displacement time graph. Here first condition we are looking at when body is at rest. So when body is at rest, so when body is at rest, whenever you are taking time on x-axis and displacement on y-axis, here as the time goes on, so at different intervals of time, the body remains at the same position as that of the initial condition of a body, initial time instant of a body. That's the reason you are going to look at it is a straight line parallel to x-axis. Therefore, straight line parallel to x-axis, straight line parallel to x-axis. Similarly, when you look at the second graph, that is when a body is moving with uniform velocity, in that case the graph is going to be, here it is time and here you are taking the displacement. Since it is moving with uniform velocity, it is going to be a straight line. It is going to be a straight line passing through the origin if origin is taken as the initial point. If initial point is taken at some distance, from that distance it is going to be a straight line. The third case we are going to look at is when body is moving with non-uniform velocity. In case of non-uniform velocity, so it is not covering the equal displacements, non-uniform velocity. In such case, it is going to be the time is here and here is the displacement. It is covering different displacements at different intervals of time. That's the reason it is going to be an irregular graph like this. So it is the case of non-uniform velocity. The fourth case we'll look at is uniform acceleration. In such case, it is going to be time is on x-axis, displacement is on y-axis. So it is going to be like with an increasing slope, a positive slope. The graph is going to be a curve like this with positive slope. This is for acceleration. So now we are going to look at the different graphs as I said. So we are going to look at the displacement time graph here. First of all, we are just looking at the various cases where the body is at rest. When the body is at rest, as time goes on, it is not getting displaced from its initial position. That is the reason as the time goes on, at different time instants, if you look at, it is going to be at the same place. The reason the graph is going to be a straight line parallel to the x-axis. That means ST graph is straight line parallel to the x-axis. That is the condition for when the body is at rest. So in case of the uniform velocity, as the time goes, it is covering equal displacements in equal intervals of time. That is the reason the graph is going to be a straight line passing through the origin. As the time goes on, it is gradually increasing. So it's a straight line. The nature of the graph is going to be a straight line in case of uniform velocity. Similarly, when it is moving with non-uniform velocity, it is not covering the equal displacements in equal intervals of time. That is the reason it is going to be an irregular graph, and it is covering the different displacements in different intervals of time. That's the reason you cannot have a proper straight line right from the beginning, and it is going to be irregular, but displacement will be either positive or negative, but it goes irregular. And in case of uniform acceleration. Coming to the uniform acceleration part, as the time goes on, the velocity is gradually increasing. That is the reason it is covering excess displacements. That means displacements are being increased. So the graph is going to be a curve with positive slopes. So these are the various graphs associated with displacement versus time.